Say we're asked to find the angle between two vectors. So if u dot v is length u, length v times cosine of the angle between them, then the angle between them will be arc cos, or cos inverse, of u dot v over length u, length v, or equivalently, cos inverse of u dot v over square root u dot u times, so this is a multiplication of numbers, not another dot product, square root of v dot v. So we calculate u dot v is -1 minus 1 minus 2 is -4. U dot u is 3, so length of u is root 3, and v dot v is 6, so length of v is root 6. So we get that theta is arc cos of -4 over root 18. And you can plug that into a calculator. This is approximately 2.80 radians, or approximately 160.53 degrees. Now let's say we're given this situation. So an object is hanging from 3 ropes, and we're told vectors pointing in the direction of those ropes. So let me call these, this will be u, this will be v, and this will be w. Then I'm going to call u hat to be the direction vector of u, so that'll be u over length of u. So then we're told that, so we'll have 20 u hat, so this will be, since we're told that's the tension in the first rope, so this force plus something in the direction of v plus something else in the direction of w, so b and c are the unknown tensions in the other ropes, and then the other force acting on this object is gravity. So gravity will be pointing straight down, so we'll have 0, 0, and then negative g, so g is going to be the weight of the object that we're after. So this, since the system is in equilibrium, will equal to 0, 0, 0. Or we can rearrange this. So 20 u hat plus something in the direction of v plus something in the direction of w is equal to 0, 0, g. So let's start by just working out what those direction vectors are. So u hat will be, okay, so the length of u is 9 plus 4 plus 1, so that'll be root 14. And then 3i minus 2j plus k. So I'm using this notation for the standard unit vectors. Then, v hat, so that has length root 3, and then I plus j plus k. And then w hat, so w has length root 6, and then this will be negative I plus j plus 2k. Okay, so now if we look at the x-coordinate of each vector, then this will give us an equation. So 20 times u hat, that'll give us 60. So we're just looking at the coefficient of the I vector on both sides. So 60 over root 14 plus b over root 3 minus c over root 6, that has to equal 0. And then we do the same thing for the y coordinates. So then that'll give us negative 40 over root 14 plus b over root 3 plus c over root 6 is equal to 0. So now if we add these two equations, then we get 20 over root 14 plus 2b over root 3 is equal to 0. So we can eliminate the variable c, and now if we solve for b, this will give us that b is 10 root 3 over root 14. Now we substitute that back into our original equation. So now we get 60 over root 14 plus 10 root 3 over 14 over root 3. So this cancels. Then minus c over root 6 is equal to 0. And that will give us that c is 70 root 6 over root 14. So now we have the values of b and c. So now, let me cordon these off. So now to find the value of g, we just add up and look what we get in the third component. So g will be 60 over root 14 plus 10 over, I'm sorry. Let me back up. No, g will be 20 over root 14 plus 10 over root 14 plus 70 root 6 over root 14 root 6. This cancels. So the weight we get is, plus 2 times 70 root 6 over 14 over root 6. So this will be 140. And so we end up with 170 over root 14 pounds is the weight of the object.